All right, this last one's a little tricky because there's a couple steps that you want to do to prepare for the actual sum. And the first thing I'm going to do is recognize that at some point I'm going to have to deal with a first power sum and a second power sum. So I've got my formulas written down, ready to go. But I also see this guy hanging out here, which is sort of interesting, and we'll address that in just a moment. But the first thing I want to do is rewrite this so that I've got the three different sums separated. Okay, so to rewrite this, I can write it as the sum from n equals 1 to 10 of just 3 minus the sum from n equals 1 to 10 of 1/2 n plus the sum from n equals 1 to 10 of 1/2 n squared. Now I'm going to do one more thing and then we'll apply our formulas. And what I'm going to do is I'm going to sort of bring out, I guess you could say, or factor out really, these 1/2s, okay? Because I only have a formula that shows me how to calculate a first power without any coefficient. So I'm gonna write that in front. We talked a little bit about that in the video, or Mr. Middleman did, in the video of how you can bring that coefficient out in front of your sum, and then whatever your sum is, you multiply it by that coefficient. So it would look like this: 1/2 times the sum from n equals 1 to 10 of n, and then plus 1/2 the sum from n equals 1 to 10 of n squared. Now what I've got is three distinct sums that I can use my formulas to find. And I'm going to use my green formula that I've highlighted above for that one, and my blue formula that I've highlighted above for this one. Now the last one, or I guess really the first one that we see here, this one, is a little tricky, but let's just kind of think about what it's telling us to do. Okay, so no matter what n is, doesn't matter what n is, our output's always 3. So our sequence is just going to be a whole bunch of 3s. In fact, it'll be from 1 to 10, those term numbers are all just going to be 3. So really what we're seeing in this sequence is just 3, 3, 3, and we'll go up to 3, and this will be 10 times. So really this sum is pretty easy. It's just 10 times 3, because there's 10 terms, and all of those terms are 3. That's our first sum. Then we're going to subtract from that 1/2 of the sum for that first power. So the sum of the first power, again substituting here, 10, because that's our highest value of n, ends up being 10 times 10 plus 1 all over 2. That's our first power sum. And then plus 1/2 times, now we use that second power sum, and again replace all of our n's with 10s. So we're going to have 10 times 10 plus 1 times 2 times 10 plus 1 all over 6. And then at that point it's a lot of just simplifying. So my first sum, or my first term here, is just 30 minus 1/2 times, and then we've got 10 times 11 all over 2 plus 1/2 times 10 times 11 times 21 all over 6. Now we can use our calculator, and I'll go through all of the simplifying with you on this one just so you can see where everything comes from. All right, so we've got 30, okay, minus 1/2 times, in blue, that's going to be 55. I'm not going through every part of that, but 10 times 11 divided by 2, that's going to be 55. Plus 1/2 times, and then if you simplify what's in the parentheses there, you get 2310 over 6. That might simplify a little bit nicer, but I'm not really worried about it because now I'll use my calculator. All right, so I'll do 30 minus 1/2 times 55 plus 1/2 times 2310 over 6, and I'm going to get the sum that you should have gotten in the question was, I think, 195. All right, nice work. If you tried this one, good job. If you got it right, even better.